Uh, Hello, sir. I am Hitosani. I am from IMTech 2020 batch, and I am doing this Ensem project individually. And my topic is multimodal customer support chatbot using MongoDB and NoSQL technologies. So let me tell you what all things will I cover in this presentation. The things which I cover in this presentation is problem statement and motivation, the approach I used, the implementation, what I implemented, the demo of the system, evaluation, and at last conclusions and lessons which I learned. So let us start with problem statement and motivation. The problem I am trying to solve is to build a customer support chatbot that can effectively handle customer queries and provide satisfactory responses. The chatbot should be able to communicate with customers in a natural language and understand the intent behind their queries. The background of this problem lies in the fact that customer support is an essential part of any business and it can be a time consuming and resource intensive task. A chatbot can automate the process of handling our customer queries, thereby freeing up resources and reducing response times. From a NoSQL system perspective, this problem is interesting because it involves processing large amount of text data which can be stored and retrieved from a NoSQL database. Additionally, NoSQL database provides scalability and flexibility which are important for handling large amounts of data. The main results and insights I intend to obtain are the effectiveness and efficiency of the chatbot in handling customer queries. I aim to evaluate the chatbot's performance in terms of accuracy and response time and compare it to human agents' performance. Additionally, I also aim to analyze the chatbot's ability to learn and adapt to new queries over time. Finally, I intend to explore the scalability of the chatbot and its ability to handle the large volumes of data. So, having talked about problem statement and motivation, now let us talk about the approach and implementation which I use. So, basically, these are some of the points of approach. I will cover approach and implementation in one go only. So basically, in this project, I developed a customer support chatbot that is capable of handling voice and text inputs using a multimodal approach. The chatbot is trained on Kaggle customer support on Twitter dataset, which contains tweets that have been labeled according to their respective customer support categories. To develop the chatbot, I first pre-processed the data by removing the stopwords, URLs, and mentioned from the tweets also the Twitter IDs. Then I used the TextBlob library to tokenize the tweets and extract their features and trained bot using simple RNN, recurrent neural network. Trained the bot means trained I taught the bot how to give the response. I chose to use this algorithm because it is effective for text classification tasks, especially when the number of features is high. To handle the voice input, I use speech recognition and PyAudio libraries. The user's voice is captured through the microphone and speech recognition library is used to convert the audio to text. This text is then passed to chatbot which generates a response based on the user's input. I used PyMongo to store the chat history and training data in the MongoDB database. This allowed us to easily retrieve the data and update the model as needed. I have used a pipeline to convert the voice input to text using speech recognition and PyAudio libraries. This pipeline consists of several steps, including capturing audio from the microphone using PyAudio, recognizing the speech using speech recognition, and returning the recognized text. This pipeline is used in getInput function to allow the user to input text either through a voice or text, making the chatbot more user friendly. My approach makes it simple and easy to build reusable pipelines that are user friendly because all the code is modular and can be easily adapted to other chatbot applications. For evaluation, I used cross validation to test the accuracy of the model on a subset of the training data. I achieved an accuracy of around 80%, which demonstrates the effectiveness of my approach. So this was all about approach and implementation. Basically, what approach I took and what I implemented. So I will show this system demo at last. Let us now cover the evaluation part. To evaluate the performance of the chatbot, I used Kaggle customer support on Twitter dataset, which consists of over 2.7 million tweets, making it a large dataset suitable for testing the chatbot's performance. I evaluated the chatbot's performance on different parameter settings such as different number of training epochs, the number of hidden layers in the neural network, and the batch size. I trained the chatbot on different subsets of data, varying the size of the training set from 50% to 90% of the entire dataset. To measure the quality of the chatbot's response, I used two metrics, accuracy and perplexity. Accuracy measures how often the chatbot's response were correct, while perplexity measures how well the chatbot's language model is able to predict the next word in a sequence of words. My experiments showed that increasing number of training epochs and the number of hidden layers in neural network led to an increase in both accuracy and perplexity. However, increasing the batch size did not have a significant impact on chatbot's performance. I also found that training the chatbot on larger subsets of dataset led to significant improvement in its performance, with the best results achieved when training on 90% of the overall dataset. Overall, my experiments showed that chatbot's performance can be improved by increasing the number of training epochs and number of hidden layers in the neural network, as well as by training on larger subsets of dataset. The chatbot achieved an accuracy of booming 80% and perplexity of 5.2, which are good results for a customer support chatbot. In terms of efficiency, the chatbot was able to generate response in real time, with each response taking less than around 2 to 3 seconds to generate. I attribute this efficiency to use the pipeline to convert voice to text, which allows for fast and accurate processing of user inputs. So, let me tell you what are the conclusions and what lessons I learned. So, basically, in conclusion, the problem addressed in this study is need for an efficient and scalable customer support that can handle large volumes of consumer queries and provide timely and accurate responses. And the lessons some lessons which I learned are like I learned and explored more about MongoDB. Then I was unaware about these libraries like PyAudio and PyMongo. PyMongo is library basically which is used to connect your Python's code to MongoDB server, and PyAudio is the library which is used to take voice input, and speech recognition is the library which is used to convert the speech to text. Basically, it recognizes the voice input which you give to the computer and converts it to text. And also learned how NoSQL can be used to solve the real life problems. Okay, so at last, let me show you this demo part. Hello. Cancel flight ticket from Goa Web. Okay. Stop. Hmm.